So hydrocarbons are the most common fuels, and these include natural gases, gasolines, petroleum oils. Those are all good fuels that are carbon and hydrogen only. This picture is of a refinery, which is where you take crude oil and you get out the natural gas and gasolines and separate out the oils from that, the different kinds of heating products and stuff you can get from that. So that's, and chemical engineers are the ones that design these to do that separation process. Just some basic about hydrocarbons that we're throwing in here just for our engineering chemistry. Hydrocarbons, the most common ones, have all single bonds. And so when you look at these structures, remember that these are the bonds, these dashes. Each dash represents a pair of electrons that are being shared. These are certainly covalent compounds because they're nonmetals. And this one has all single bonds, but this one has a double bond. So it is not an alkane because it's got a double bond. Just to give you an idea of the different kinds of alkanes, these are hydrocarbons with single bonds only. The first four are the natural gases. And that's kind of classically the first four, and they are what is in natural gas, like you use in your home on your stove or wherever. Natural gas is mostly methane, but it is a mixture. It has quite a bit of ethane and a little bit more or a little bit less of these. But anyway, it is a big mixture. And then as we get to bigger ones, these are, you may recognize the name octane. These are the compounds that are in gasoline. And when you start getting larger, you're looking at diesel fuels and stuff like that. And then keep in mind that when you're talking about crude oil, there are other compounds and stuff that are in the crude oil. There'll be alkenes mixed in and stuff like that. So usually fuels are big mixtures of different compounds. Let's look a little bit at where these compounds get their energy, because they certainly have energy stored in them. And I just like this because I like the beauty of the cycle, so to speak. So, you know, let's just talk about if this is our fuel and this is a plant, and certainly hydrocarbons came from plants long ago that were buried and got compressed, and that turned into crude oil and natural gas and stuff. So our plants were the original source of energy for our hydrocarbons. And when we burn gasoline or natural gas, we get our energy out in this process of combustion. We get energy out, but the products of that, we already said, were CO2 and water. Anytime you burn a fuel that is carbon-based with those elements, the two products are CO2 and water. Well, guess what? CO2 and water, carbon dioxide or water, what plants take in. They absorb carbon dioxide from the air, take in water from their roots, and then they take energy from the sun, and they convert water and carbon dioxide into plants. And that process, of course, is like they grow. Plants actually grow, and they make the carbon-based fuels they make that are part of the plant. They're growing, but they're also producing fruit and starch stores. Anyway, those compounds that they make, often they start by making like sugars and then complex carbohydrates and so forth. Anyway, so those carbon-based fuels end up eventually being our fuels that we can use to get energy and so forth. So it's kind of interesting because all of the energy, we could also, by the way, this process right here, Animals do this too. So we could have like a person eating. It's not combustion because there isn't a flame, but we're burning fuel when we eat our plants or animals. We're burning the fuel and breathing out CO2 and giving out water as well. So we do this part in purple. So the thing that I think is kind of interesting is that all of the energy from our fuels, our carbon-based fuels, all of that energy originally came from the sun. So we don't just need the sun to keep us warm. We need the sun to make our energy, to make our fuels, the things we eat, and our fossil fuels as well.